this video, we're going to look at the second worksheet from the Exam 2 review. So starting out here, it says, suppose that we randomly select a sample of 64 measurements from a population having mean equal to 20 and a standard deviation equal to 4. So notice this information right here is concerning the population distribution. So in part A, it says describe the shape of the sampling distribution of the sample mean x bar. Do we need to make any assumptions about the shape of the population? Why or why not? So remember that when working with the sample mean x bar, there are two different conditions that we could have to know what the shape of the sampling distribution is. We either need the population distribution to be normal, or we need a sample size that is large enough for the central limit theorem to apply. So notice in this case, we're going to select samples of 64 measurements. In other words, n is equal to 64. So since n is equal to 64, which is bigger than or equal to 30, we know the central limit theorem applies. And what that tells us is that the sampling distribution of x bar is normally distributed. Now, if n had not been greater than or equal to 30, then in order to know the shape of the sampling distribution, we would need to make the assumption that the shape of the population distribution is normal. So next we're going to find the mean and the standard deviation of the sampling distribution of the sample mean. So if you will recall, and you can look at your formula sheet for this, the mean of the sampling distribution of x bar is centered at mu, which is the population mean. So in this case, notice that the population mean is 20. And the standard deviation of the sampling distribution is given by sigma divided by the square root of n. So in this case, our standard deviation is equal to 4. That's our population standard deviation. And n, which is our sample size, is equal to 64. So this gives us 4 divided by 8, which is equal to a half. And if you want to, you could convert that to decimal form. C, can you find the probability that a single measurement will be greater than 21? If so, what is the probability? So notice, since we're interested in a single measurement, what this tells us is we need the population distribution. But notice in this case, we do not know the shape of the population distribution, so we cannot find the probability. Next, it says calculate the probability that we will obtain a sample mean. So notice here we're describing the behavior of the sample mean, and we need the sampling distribution. Well, up above, we already described the sampling distribution, so we can find this probability. So the first thing I'm going to do is sketch what the sampling distribution looks like. We already said by the central limit theorem, it's going to be approximately normal. We also know that the mean is at 20, and we know that the standard deviation is equal to a half. Right, and we want the probability that we get a sample mean greater than 21. So in other words, we're looking for this area under the curve. So the first thing we're going to do is find our z-score. Oops, sorry, I've got these backwards. That should be 20. Oh, darn it here, 21 minus 20, there we go, divided by a half, which is equal to 1 divided by a half, which is equal to 2. So going to our z-score table, looking at a z-score of 2, we find the area to the left is 0.9772. So if we want this area, we need to take 1 minus the area to the left. So what this tells us is the probability that the sample mean is bigger than or equal to 21 is equal to 0.9772, and we need 1 minus that value. So if we put that in our calculator, we'll find that's equal to 0.0228. All right, let's look at the second page. All right, the second page reads, according to the 2017 Australia Census, P equals 65.6% of students were enrolled in government schools. Assume we were to take random samples of 100 students. So notice this is telling us that N is equal to 100. And calculate the proportion of children enrolled in government schools. This data comes from the Australian Census Bureau. All right, so what is the mean and the standard deviation of the sampling distribution of the sample proportion of children enrolled? All right, so we need our mean and we need our standard deviation. Well, if we go and we look at our formula sheet for the sampling distribution of the sample proportion, we will see that the mean is located at the population proportion, and we'll see that the standard deviation is equal to P times 1 minus P divided by N. So in this case, we're given P up above, but we want to write it in decimal form. Filling in the formula for the standard deviation. And take a moment and we'll put that in your calculator. And I found this was equal to 0.0475. Now in terms of interpreting these measures, what this means, well, I should say what the mean represents, is if we were to take lots and lots of samples of 100 children, we would find that on average, those samples of 100 children would have 65.6% of them enrolled in government schools. The standard deviation, what that tells us is we can use it to say, by the empirical rule, that the mean plus or minus 2 times this value will give us a range where 95% of those sample proportions taken from 100 children would fall. Question 2. Is it reasonable to assume the normal shape for the sampling distribution of the sample proportion of children enrolled in government schools? Well, to answer this, we need to do our assumption check for the central limit theorem. And you'll remember part of that assumption check is we need to check that N times P is bigger than or equal to 15 and N times 1 minus P is bigger than or equal to 15. Well, in this case, N times P is equal to 100 times 0.656, which is equal to 65.6, which is obviously bigger than or equal to 15, so that one is good. And then we also need to check N times 1 minus P, which is equal to 100 times 1 minus 0.656. And that is going to be equal to 34.4, which again is bigger than or equal to 15. So again, we are good. All right, part 3. Given that P is equal to 65.6 of students were enrolled in government schools, what values of the sample proportion would you expect to observe from samples of 50 children? So notice now we're going to work with a new N. We're changing N to be 50 for this problem. All right. So first thing we need to do is describe our sampling distribution again. So remember that our mean is going to be equal to P, which is 0.656. Our standard deviation is equal to the square root of 0.656 times 1 minus 0.656, but this time we're going to divide by 50 instead of 100. Take a moment, double check that with your calculator. And so remember that by the empirical rule, if we want a range of where 95% of the values of the sample proportion would fall, we could always take the mean plus or minus 2 times the standard deviation, or in this case 0.656 plus or minus 2 times 0.0672. Now some books will have you could have also have put a 3 here instead, because remember the empirical rule tells us that within 2 you get 95%, within 3 you get 99.7, so I would count either one of those correct. Now on an exam I might be more explicit and I might say, would we expect to observe 99% of the proportions or something along that line, but as long as you put a 2 or a 3 here, that would be correct for this problem. And then finally it says, how likely is it that a sample of 50 children will have less than 60% of the students enrolled in public schools? Again, what we're going to do is describe the sampling distribution. Now if you take samples of 50, the central limit theorem does still hold, and I'll let you check that on your own. So we are going to have a normal sampling distribution. Its mean is going to be at 0.656, which is our mean that we have here. And then we know its standard deviation. Since we're taking samples of 50 students, it's going to be this standard deviation, which is 0.0672. And we want to find less than 0.6. So notice 0.6 is over here. So that's the area that we want for this problem. So the first thing we're going to do is calculate our z-score. Get out our calculator. And I get a z-score of negative 0.83. So again, we're going to go to our standard normal table. And remember that our standard normal table always gives us areas to the left. And we're going to look up negative 0.83. So here we have negative 0.8. If we go over to 3, we get 0.2033. So this area here is 0.2033. So what this tells us is that the probability that the sample proportion p hat is less than or equal to 0.60 is equal to 0.2033. And this concludes the video for this worksheet.